My name is June Lopez, and I'm the General Manager of Molten Miguel Water District. And today I want to share with you the story of data and water. It's a story about how people came together to do good for others. The story starts with the water industry not having open, transparent, and accessible data. We had data, but they were in file cabinets, boxes, and different formats. And it wasn't standardized and centralized to where we can actually extrapolate meaningful information. But more importantly, it wasn't in a format that we could work with other stakeholders like academic institutions, private sectors, other entities that wanted to apply their skills, their knowledge and expertise to help solve water problems. So it was a big barrier for us. And in developing policies and decisions, while we knew that we had to take certain course of action to ensure we preserve and conserve our precious resource, we just didn't have good enough data to make the kind of informed decisions and be able to tell our story with very compelling facts. So we went through this for year after year, and we realized at one point something had to change. And it started over a lunch conversation between myself, one of my staffers, and his brother. And this was 5.5 years ago, at the height of the California's worst drought in history. And we realized that regulations and mandates needed to happen to be able to manage our scarce water resource. What kinds of data existed to be able to help us make better decisions going forward? And when we saw this as a gap, we thought, what can we do? Because sure, there's something we can do. And we decided to reach out to our friends in different agencies throughout the state, pulling together a very talented team of staffs, and really try to take all the data that we have, which were disorganized and messy, and clean it, standardize, centralize it, and work together to see what we can learn from each other and what we can come up with. And we got other partners outside of water. We got academic institutions, we had private sectors help us out, private tech companies. And 5.5 years later, this grassroots effort that started with a phone call is now a nonprofit that represents 21 million Californians. And every year we have a capstone event to highlight the great work that's been done of how data and people with great minds and great heart use this powerful tool to help all of our communities in California. And these success stories continue to pay it forward. Those who helped us, those who gave us their expertise for free, their help, their time, have also been successful in using these success stories to get additional funding to support their efforts. This has not just become a network of professionals. This has become a circle of friendship, a community of practice where we continue to iterate, learn from each other, and develop a relationship that will last a lifetime. Now, that grassroots effort also helped to galvanize the commitment to having better data to serve all Californians. And we've got so much support from the state agency. And a few years ago, a legislation was passed to bring all of state's water data into open and transparent platform. And now we have a state-involved, state-led effort involving all the different stakeholders to look at how we can do this at a statewide level in a much more meaningful and integrated way. So the California Data Collaborative, working in conjunction with the California Water Data Consortium, a nonprofit that was born out of the legislation and in partnership with the state agencies and all the stakeholders, it's truly a book and a collaborative approach to making sure from top down and bottom up that we are using and leveraging the power of data to do good. And it's inviting all kinds of stakeholders that weren't part of the picture before. It's bringing us diversity. It's finding a place for everyone. Because in water, everyone belongs and everyone has a role. And how the story ends, well, that's up to you. Because the story is just beginning. And it is exciting. And the future is ever so bright. It is transforming how we do business, how we serve the public, how we get you involved because we need your participation. No matter who you are, what background, there is a need for your participation, your help in making sure that we have this critical service for years to come and we are improving the way we deliver those services. So help us write the rest of the story and make it the story that you want to hear about for generations to come. And that is my request to you. Get involved. We need you. And that is why data excites me, because it brings people together to do amazing things. So let's do it together. Thank you.
Hi everyone, my name is Jonathan Cruz and I'm the Director of Financial Planning and Innovation at Molten Miguel Water District. Thank you for joining me today as I'm going to take you through an intro of the increasing role that data and more specifically data science skill sets play in the day-to-day operations of a water utility. Here's a quick overview of the topics and concepts that we'll be covering in today's lesson. First is to develop an understanding of the role that data plays in the daily operations and long-term planning of water utility providers. Second, to illustrate the role of data scientists in informing policy by transforming data into information through visualization. And third, to understand how multiple measurement data sets can be combined to answer more complex or nuanced questions than can be done individually. Molten Miguel Water District provides potable water, recycled water, and wastewater services to over 172,000 people in South Orange County. And we do so by maintaining over 1,300 miles of water and wastewater pipelines, and 90 plus reservoirs and other critical facilities that we utilize to get that infrastructure, or that we utilize to get that water delivered to our customers. And of course, to make sure that water is safe, we conduct over 12,000 water quality tests per year. And so what that really means is that we have a lot of data coming from a lot of different systems, but it's not so easy to make those data sets speak to each other. And so this is where data science, and hopefully one day you, come in. That really, data doesn't do anything by itself. It takes analysts and data scientists to turn data into actionable information that we can put in the hands of decision makers. So I mentioned at the beginning of the video that I'm the Director of Financial Planning and Innovation, which means I oversee traditional finance functions like budget development, rate setting, and customer billing. But I also oversee Molten Miguel's data team, who are responsible for developing not just reports for staff, but probably most interestingly, apps to help our customers understand their water usage and bills. And so really the key to all of that is that data is playing an increasing role in utility operations and resource planning. And the volume of data that we're seeing is increasing at an even greater rate than the role that it's playing. A great example of that is the smart meter data that we're now collecting at Molten Miguel. For those of you who might not know, smart meters are water meters that are able to report hourly water usage information wirelessly over a radio network. And this is great because we no longer have to wait for a field technician to physically visit up someone's property or a meter for monthly readings that we would use to calculate bills before we can start to see usage data and identify trends or leaks. Now we can actually see that at an hourly level several times per day. And so really this provides us with a lot of opportunity to, again, see new patterns that are emerging and also notify customers of potential leaks they might have or let them see changes in their own hourly usage. As recently as 5 or 6 years ago, we had some customers who were only getting one bill every 2 months, which means for that customer, we had only 6 data points per year. With smart meters, that really changes because now all of a sudden we're able to collect 24 points of data per day. And what that means is that every single day you have 4 years worth of data. And so what that means and as it relates to the entire district is that, in the past, we might have had as few as about 330,000 meter reads in a given year. Well, as you can see in this chart on the left of the screen, in the first day that we're using AMI for the full district, we actually have 1.32 million meter reads. So you can see that's already quite a lot. And as we continue, that trend is just going to continue. On day 2, we now have 2.64 million reads. After the first week, we have 9.24 million reads. After the first month, we have 39 million reads. And then after a full year, we have 475.2 million reads that we previously would have only had a small fraction of. And so what that really means is that, even though this data can provide valuable insights, the water industry's traditional methods of processing and analyzing this data have quickly been outpaced by the sheer size of the data. And again, this is where bright minds like you come in. There's a growing need for data science skills in the water sector. But with that, it's important to understand data fundamentally so that you can visualize it to present this information to not just subject matter experts in the field, but also policymakers that are deciding how to plan for future resources. So with that, I wanted to break really quickly for a data visualization quiz. So as part of this data viz quiz, which city do you think this weather belongs to? So city X in the background there, we can see over time that's in about January of 2015, they had a low of about 5 degrees. And in what I'm gonna guess is about July of 2016, they had a high of 33 degrees, really warm. So where do you think this is? Is it A, Juneau, Alaska, B, Winnipeg up in Manitoba, Canada, C, Mission Viejo, California, D, Scottsdale, Arizona, or E, a research base in Antarctica, which isn't really a city, but in any case, definitely a place that's very cold. The correct answer, of course, is C, Mission Viejo, California. Now, if you might have guessed that it was a place very cold, that's because you were likely looking in the units that you were expecting to see. So I mentioned it had a high of 5, or excuse me, a low of 5 and a high of about 30 degrees. Well, that was in Celsius. So when I convert it into Fahrenheit, you can actually see the weather in Mission Viejo in a way that you would expect to see it, which is, hovering in the 60s to 70s. Metadata matters because it tells you information about the data. So the series of temperature readings that we have, are they in Celsius or Fahrenheit? The water volume usages that I'm showing, are they in months or years or some other kind of units that might make comparison not as straightforward? And so again, this is where the role of the data scientist comes in and is able to go and take this information about the different types of data and bring them together to help answer questions that they wouldn't have been able to just with those data sets alone. And so with that, we're going to jump into a fun visualization exercise that really helps to understand just how usages or water usage has changed in our area. So with that, let's jump into a data visualization exercise that will help to illustrate how combining multiple sets of data can create a more complete picture of really what's happened or the area that we're trying to research. Given my role in finance, it's important that I understand how customers' water usage behavior is changing over time. And so does that mean, is there a changing in trend where customers are using more or less water? And so because of the importance of that question, understanding that trend over time, it's important that I visualize the data the right way. So in the chart that you see here, you can see a series of peaks and valleys. And really what that represents is changes in water usage during the year. So when you see those peaks up at the top, that means that that's a summertime period. And then when you see the valleys at the bottom, that's a winter period. Now, if I'm trying to understand a long-term trend over time, seeing the data this way doesn't really help me. It shows me how things change from summer to winter. But if I'm looking to see how things change year over year, it's a little bit harder to see that. So one of the options that I have for that is to manipulate the data and change it into units and time intervals that make the most sense. So in this chart, you can see that I've converted the water use, the very spiky water use that was month by month, into annual water usage. And so now you can definitely see a trend. And so looking all the way back to 1991, usage was a little bit over 30,000 acre feet. Now, for the purpose of this exercise, you don't need to worry about what an acre foot is, but just know that it's different than what customers, the units that they're billed in. So they're not billed in acre feet, they're billed in a different unit, but this is the unit that makes the most sense in terms of presenting this data. And so what we can see is that water usage definitely increased through the 2000s, and then all of a sudden started to pretty rapidly decline. And now we see that we're down at about 25,000 acre feet per year in 2020. So really there's some kind of change that's occurred at some point. And so with the first part of it, I mean, we could definitely see there's an increase in water use. And so even though we see this trend just from this image, it doesn't really tell us the full picture. So what what caused that? And that's not something that this chart can tell us, but it is something that we might be able to answer if we bring in supplemental data sets. So one source of supplemental data that might help us better understand what's driving those changes in water usage over time in the service area is population. I mean, one straightforward conclusion would be that, well, population increased, and so water usage increased, and then water usage decreased. That means population must have also decreased. That'd be pretty straightforward. But when we look at the population data, which is what you see populated in the chart here on the left, is that population did in fact increase in the beginning, so that fits the explanation that we came up with initially. But then population still increased in the future and definitely didn't decline the way that water usage declined. So by adding this piece of supplemental information, we can maybe get a more clear picture of what actually occurred. So when I take those two different data sets and I pair them together, I can really put these trends together. And so what we can see, again, the blue bars in the background are total water usage that I showed you previously. Now the red line is the population line that we had from the prior chart. And so when you put those together, what you can see is that, yes, initially from about 1991 through about 2000, water usage and population were both increasing. More people means more water use. But then all of a sudden, right around 2000, and then markedly at about 2009, 2010, you see population stay about the same, but water usage start to decline significantly. And for those of you who know, spoiler alert, there was a big drought in that 2009, 2010 period. And then, of course, most recently in the 2015 timeframe. So really what we can see here is that people now, even though they're using less water in total, that's not just because there's fewer people, it's because people are using water more efficiently. And so to get a full picture, I've added in a couple more features to this chart. And so what you can see is that compared to the population in 1991, that were using about 255 gallons per person per day, today's customers are using about 137 gallons per person per day. So they're using roughly half the amount of water that their 1990 counterparts were using, so which is fantastic when it relates to how efficient our customers are being with their water use. But it does also mean that planning for infrastructure and supply and things like that that assume that people are using water like they were in 1991 really is no longer reflective of how they're using water today. So it's really important that we were able to go and pull together those different data sets and then be able to put them together so that we could get an understanding of how people are using water. So if I'm expecting an increase in population or not expecting an increase in population or a decline, how do I plan the infrastructure sizing so that I'm assuming the right amount of water for the number of people that I have and what their water use looks like? So I hope that today's lesson helped you develop an understanding and appreciation for the role that data plays in the daily operations and long-term planning of water utility providers. And to be able to see the power that data scientists have to inform policy by transforming data into information through visualization. And specifically with the lesson at the end, to understand how multiple measurement sets can be combined to answer more complex or nuanced questions about water usage and data in general. So with that, thank you, and I hope to see you in the water data field soon.